بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. النهاردة إن شاء الله اليوم سنتطرق إلى درس جديد تابع The Center of Gravity of Rigid Body. طبعا احنا عارفين مركز الثقل مهم جدا جدا في الوحدة الأخيرة في مادة الاستاتيكا. وطبعا الوحدة الأخيرة دي مهمة جدا لأن هي تعتبر 1/6 من ال subject of static، يعني هي تعتبر 1/6 من المنهج كله. والامتحان معظمه طبعا هيبقى مالتي تشويس، اختيار من متعدد. قبل ما تختار عزيزي الطالب لابد انك تفكر قبل ما تختار الحل الصحيح. Center of Gravity هي مرتبطة برول xg equals m1 x1 plus m2 x2 2 mn xn over summation of all mass. Also yg equals m1 y1 plus m2 y2 plus mn yn over summation of all mass. To determine أو تقدر تحدد عزيزي الطالب the center of gravity of regular shape. We can know that نحن المفروض نعرف ان لو في عندي density uniform rod يبقى mid point the center of gravity اكيد موجوده في الميد بوينت. طبعا الرولز ديت اخدناها قبل كده في الحلقات السابقه. Welcome my dear student in our math program for secondary 3. Today we are follow the center of gravity of rigid body. Remember my dear student, center of gravity of rigid body as equilateral triangle is the center or centroid. What is the centroid? The centroid is intersection point of medians of or heights. Also, if we have lamina as shaped square, what is the center of gravity lie? The center of gravity lies the center or intersection point of diagonal of a square, of rectangle, equilateral triangle, midpoint of centroid, or the point lies on the median which divided the median as ratio 2:1. My dear student, look at the examples about the center of gravity. Look at my dear student this example. Find lamina of uniform thickness and density and its mass for mass in form of rectangle ABCD. AB equal 8 centimeter, BC 12, its diagonal are joined to intersect at E. Then the triangle ABE is removed. Mass of magnitude 2, M to M are placed at vertices A, C, D, E respectively. Determine the center of gravity of the system, and the system is freely suspended from D. Prove in case of equilibrium the vertical line passing through suspension point bisect angle ADC. Solution. Look at my dear student. ABCD is rectangle. Its length BC 12 centimeter, AB 8 centimeter. To determine the center of gravity of the system, the mass of triangle EAB equal quarter the mass of rectangular lamina equals M. Why? Because the lamina of rectangular for M. Why? Mass of AB triangle ABE equal quarter of lamina ABCD. Excellent student. Area of triangle ABE equal quarter of area of rectangle ABCD. Then we have ratio between area and mass. area equal quarter, mass equal quarter. If we have removed, then the mass is negative m. This is called negative mass. My dear student, it's negative mass, negative m. Then fix the mass at vertices A, C, D, and E. And choose the two perpendicular directions DA, DC represent dx, dy. Therefore, the point of intersection of medians of triangle BAE by centroid M1 x1 plus x2 plus x3 over 3 y1 plus y2 plus y3 over 3. At A, the point A, 12, 0. Point B, 12, 8. Point E, 6 and 0. Therefore, we find the centroid of triangle ABE. Then we deduce that this point 10, 4, G1, represent G1. Form the table, add G1, add E, add A, add D, add C. We have 5 mass. Add G1 negative M, add E 5M, add A M, add DM, add C to M. X coordinates 10, 6, 12, 0, 0. Y coordinates 4, 4, 0, 0, 8. Therefore, xg equals by the method negative m times 10 plus 5m times 6 plus m times 12 over 8 equal 4. Yg by the same method equals 4. Then we deduce that center of gravity of the system 4, 4. Look at, my dear student, the line which inclined dA by angle theta. As suspending from D, my dear student, in triangle G and D. We know that tan theta opposite over adjacent. Gn over Dn equals 4 over 4 equals 1. Then what is the angle? 45. By using calculator, shift 10, 1 equals 45. Then theta equals 45. The vertical line which inclined with dA by angle 45. The vertical line passing through D bisect angle ADCY because angle is 90. Now we are translate to another example. ABCD square, side length 10 centimeter, mass of magnitude 12, 8, 6, 4 gram are fixed at vertices ABCD respectively. And mass 20 gram is fixed at midpoint of AB. Determine the center of gravity of the system. Solution. Let the x, y are two orthogonal axes as shown in the figure, then form the table. Look at, my dear student, the table represent the first row represents a point A, point B, point C, point D, point E. Second row represent mass. At A 12, at B 8, at C 6, at D 4, at E 20. X coordinates 10, 10, 0, 0, 10. Y coordinates 10, 10, 0, 0, 10, and 5. By using the rule, the center of gravity of the system, xg, m1 x1, or 12 times 10, from the table, m1 times x1, m1 12, x1 10, m2 8, x2 10, m3 6, x3 0, m4 4, x4 0, m5 20, x5 10. Summation of all mass 12 plus 8 plus 6 plus 4 plus 20. Then, my dear student, xg equals 8 centimeter. By the same method to calculate yg. Yg equal m1 y1 plus m2 y2 and so on over summation of all mass, then equal 5.2 centimeter. The center of gravity is 5.2 with respect to point C. Now we are translate to another title, negative mass method. My dear student, look at, suppose we have a rigid body of mass m. This a rigid body, its mass m. Center of gravity, its symbol g. And we remove the part 1, its mass m1. Part 1, its mass, or divided the rigid body into two parts. Part 1, part 2. Part 1, its mass m1 and the center of gravity g1. And it's required to find the point g2, which is the center of gravity of remaining part. If we have rigid body and we remove one part from it, the remaining part, its center of gravity g2. How to determine g2? Whose mass? m minus m1. My dear student, we have rigid body as the figure, and we divided into two parts, or we removed one part, or cutting one part from it. The rigid body, its mass m, and we cut from it a part 1, its center of gravity g1, its mass m1. The required how to determine g2 or center of gravity of remaining part m2, its mass m minus m2. Let, my dear student, r1, r2, rg position vector of the point g1, g2, and g, respectively, with respect to origin point O. Then we deduce that rg m1 r1 plus m minus m1 r2. What do you mean m minus m1? Is the mass of the remaining part over summation of m1 plus m minus m1 or m. Then by using cross multiplication we deduce that mRg equal m1r1 plus m minus m1r2. Therefore, m1rg equals m1r1 or m minus m1r2 r2. Therefore, mRg minus m1r1 over m minus m1. And we can write this relation in terms of components and directions of orthogonal coordinates axis OX and OY as follow: mx minus m1x1 over m minus m2, y2 by replace x and y, my minus m1 y1 over m minus m1, where x, y, the center of gravity of the original body with mass m, and x1, y1, center of gravity of the removed part whose mass m1. This rule determines the position of G2, which gives the center of gravity of remaining part as if that part was formed of two bodies. The original body of mass m, the removed body, consider its mass is negative. Y is removed. This is called negative mass, negative m1. Now we are translate to example to clear that the position or the gravity for the center of gravity of remaining part. For equal mass, each of 200 gram are placed at the vertices of square A, B, C, D. Determine the center of gravity of the system, and if the mass placed at C is removed, determine the center of gravity of remaining system by using the negative mass method. Solution. My dear student, look at, we have four mass equally 200 at A, 200 at B, at C, at D. We know that the center of gravity of the square intersection point of its diagonal, point E. Let E the center of the square A, B, C, D, and the square side length equals L. The square side length equals L. Let AX, AY two perpendicular directions, and A is the origin point. We form the following table. Look at the first row, vertices of A, B, C, and D. Second row represent mass. M at 200, M at A 200, at B 200 also, C 200, D 200. X coordinates 0, 0, L, L. We suppose the side length of a square is L. Coordinates of Y 0, L, L, 0. By using the rule m1x1 plus m2x2 plus m3x3 plus m4x4 over summation of all mass 200 plus 200 plus 200 plus 200, 800. Then to determine xg equals 200L plus 200L over 800 equals half L. This the coordinates of the center, coordinate of x of the center of gravity, half L. By the same method, yg equals by or from the table 200L plus 200L over 800 equals half L. Then we deduce that the center of gravity of the system half L, half L. X G half L, Y G half L. At midpoint or the point intersection of its diagonal E. After removing the mass 200 existed at C, look at the point C, its mass became negative 200. Why? Is removed. The mass at C is removed. Cut off its mass with negative mass. Then the mass at E is 800. Why? The mass of system. Its center of gravity from the previous L over 2, L over 2. But at C became negative 200. What is the coordinate of C? LL. Why? Because we suppose AD equals L, DC equals L. Then we form table has 2 points, 2 vertices E and C. What is the mass at E? 800, at C negative 200. X coordinate at E L over 2, at C equal L. Y coordinates at E L over 2, at C is L. Then the center of gravity of remaining part equals 800 times L over 2 negative 200 times L over 600. Why? The 800 minus 200 equals 600. X G dash 800 times L over 2 minus 200 times L over 800 minus 200 equals third L. Also Y dash G 800 times L over 2 minus 200 times L over 800 minus 200 equals third L. Therefore, G dash third L, third L. Then the removed mass or remaining body, its center of gravity as distant third length of L respect to the point A. Third L, third L. Another example. ABC is equilateral triangle of side length 30 centimeter. D is point intersection of its median. We know that the median of equilateral triangle is height. The median perpendicular the base. E is midpoint of BC. Mass of magnitudes 20, 40, 30, 60, 50 gram are fixed at point fixed at the points A, B, C, D, E respectively. What do you mean? 20 at A, 40 at B, 30 at C, 60 at D, 50 at E. Identify the center of gravity of this system. Then, where does the center of gravity of remaining system lie with respect to the vertex C if the mass excited at B is removed? Solution. Let CX CY be two perpendicular directions and C is the origin point. Look at the opposite figure. C is called represent origin point. We have mass at C 30 gram, at B 40 gram, at D 60, at A 20, and at E 50. From the figure, we get the length of AE equals 30 times root 3 over 2, or 30 sine 60, 15 root 3 centimeter. We know that DE equals third AE. AE equal 15 root 3. Then DE equal 5 root 3 centimeter. What you mean? Coordinate of D is 15 and 5 root 3. We form the table. Vertex A, vertex B, C, D, and E. Masses at A 20, at B 40, at C 30, at D 60, at E 50. X coordinate at A 15, at B 30, at C 0, at D 15, at E 15. At coordinates at Y of Y, at A 15 root 3, at B 0, at C 0, at D 5 root 3, at E 0. Then to determine xg by using the rule m1 x1 plus m2 x2 2, so m4 x4 over summation m1 plus m2 plus m3 plus m4 plus m5 equal 15 3/4 centimeter, yg by the same method. Then we reduce that yg 3 root 3. Then the center of gravity of system 15 3/4 and 3 root 3. My dear student, after removing the mass 40 gram exists at B, we obtain or form the table at G and B. Mass at G 200, B negative 40, X coordinate, Y coordinate by the rule X dash or XG dash equals 12 and 3 over 16. Also YG dash by the same method 15 root 3 over 4. The center of gravity of the system after removing mass 40 gram at B is G dash 12 3 root 16 and 15 root 3 over 4. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.